Welcome to question 5 of the 2014 Mathematical Methods Exam 1. In this video we will be looking at the solution and examination advice for this question. A reminder that this video is in no way endorsed by VCAA. For question 5 we consider the function f with a domain of -1 to 3 with both of those points included by the square brackets, with the rule f of x equals 3x squared minus x cubed. For part A we're asked to find the coordinates, so that's important, of the stationary points of this function. And whenever we think about stationary points, we know that solving f dashed of x equaling 0 will find the x values of the stationary points, and then we'll just have to find the y values to complete the question. So for the function f, its derivative f dashed of x is going to equal, and that will become 6x minus 3x squared, and we want to set that equal to 0 to find the stationary points. So therefore, as this is a quadratic equation that we're solving, we're going to factorise 3x out as a highest common factor, leaving behind 2 subtract x, and we know that still equals 0. So therefore, using the null factor law, we know that 3x could equal 0, or that 2 subtract x could equal 0. So our values for x are x equals 0, or x equals 2 are stationary points on this graph. Next we need to find the coordinates, so we simply substitute that information back into our functions. So f of 0 is simply equal to 3 times 0 squared minus 0 cubed is simply 0, and f of 2 is going to equal 3 times 2 squared minus 2 cubed, which is going to equal 3 times 2 squared is 12, minus 2 cubed is 8, so we have 12 subtract 8 gives 4. So the coordinates are 0, 0, and 2, 4. So that is the answer to part A of this question. From the examiner's report, we can see that 66% of students got this question correct, and that the examiner goes on to say that students must be vigilant in ensuring they answer the specific question. In this question, coordinates were required, and not simply the x values. Some students omitted the turning point at 0, 0, and others incorrectly found the x-intercepts rather than the stationary points of the graph. For part B, we're asked to sketch the graph of f on the axes below, and we need to label any endpoints with their coordinates. So to help us sketch this graph, we already know where the stationary points are. And from the previous question, we knew they occurred at 0, 0 and 2, 4. So that means there's a stationary point here at 0, 0, and at 2, 4, which is up here. So the point of 0, 0 is also found an x and a y-intercept. So what we need to do now is find the other key features of this graph. Importantly, we need to find the endpoints. So one endpoint occurs when x is -1, so we evaluate f of -1 is going to be 3 times -1 squared minus -1 cubed, and that's going to equal 3 times, and -1 squared is +1, so we have 3 times 1 is 3, and then -1 cubed is still -1, so we're going to have subtract -1, which is just +1, so that's going to equal 4. So at -1 we have a y value of 4, and it's going to be a coloured in dot because it's a square bracket for that endpoint. The second endpoint is at 3, so f of 3 is going to equal 3 times 3 squared minus 3 cubed, which is simply going to equal 27 subtract 27, which equals 0. So we're going to have a coloured in dot at 3, 0. And now, just so we're as accurate as possible, we can evaluate f of 1, which is the last x value that has a grid line associated with it, because we've found -1, 0, 2, and 3. So f of 1, when we put it in there, is simply 3 subtract 1, which equals 2. So we know that the graph's going to go through that point as well. So sketching a cubic graph through all of those points, it's going to look something like this. And just to check that we've answered the questions, we need to label the endpoints with their coordinates. So this is -1, 4, and this is 3, 0. So that is the final answer for our question. From the examiner's report, we can see that 63% of students got this answer correct, so it was reasonably well done. And the report goes on to say that correct responses to this question required a smooth curve rather than sharp V shapes at the turning points. The endpoints also needed to be clearly labelled with their coordinates. As well for full marks. For part C of this question, we're asked to find the area enclosed by the graph of the function and the horizontal line given by y equals 4. So the line of y equals 4 on a computer generated version of the graph we just sketched is this line here. And we can see that the region enclosed is going to be this part here. And now we know that that area is going to be given by the integral between -1 and 2. So they are the x values between the points of intersection of the function and the line y equals 4. Because we previously found this value here to be 2, 4. And then we're going to have our upper curve, which is simply the function y equals 4, subtract away our lower curve, which has a rule 3x squared minus x cubed. And that integral is going to be with respect to x. And we can just do some simplifying here. So this is going to be between -1 and 2. And this is going to become, the two negatives here will become positive x cubed. And then we're going to have negative 3x squared. So that's our expanded simplified integral. So to evaluate that, we're going to find the antiderivative. So x cubed goes to x to the power of 4, and then we divide by the new power. And then we have minus 3x, and when we add 1 to this power, we'll get x cubed. And dividing by 3 will just leave negative x cubed. And then the plus 4 will integrate to plus 4x. And then we're going to evaluate that still between -1 and 2. To evaluate that, we're going to substitute in the upper terminal. So we're going to have 2 to the power of 4 is 16 over 4. And then we're going to subtract 2 cubed is 8. And we're going to add on 4 times 2 is 8. And then we subtract away the antiderivative with -1 substituted in. So -1 to the power of 4 is +1, so we get a quarter. And then -1 cubed is still -1, so subtract -1 gives +1. And then 4 times -1 gives -4. And then simplifying that, we get 16 over 4 is simply 4 in our first bracket, and the -8 plus 8 will cancel, so we're just going to have 4 subtract the second bracket, which has the equivalent of -3 plus a quarter, which can be written as -11 on 4. And then this is going to be the same as 16 on 4, subtract -11 on 4 is plus 11 on 4. So now we have a common denominator, we can simply add them to get the answer of 27 on 4 units squared. So that is the answer to part C of this question. So from the examiner's report, we can see that 21% of students got this correct, with many students making progress along the way. Most students knew to seek a difference of 2 areas, and they were adept with basic integration. However, quite often, arithmetic errors in evaluation or incorrect use of negative signs marred students' progress towards acquiring the full marks to this question. Some students unnecessarily overworked the problem by creating 3 or 4 integration statements and dealing with them, which increased the likelihood of an error. And a few students were seen to take a more direct route that involved the symmetry of the curve.